Today is going to be two examples of solving some more complicated quadratics that are not necessarily in any of the forms that we've seen so far. One of these examples you guys are doing on day 8 of the lesson before you work on a practice type 3 of solving all methods. And the other one is actually part of day 10's lesson before you guys take the longer quiz, which you will get the majority of the period to work on that longer quiz instead of a typical 10-minute quiz. So we're going to do two of them. They're both going to be in this video. Again, one example is day 8 and the other example is day 10. So let's start the first one. For both of them, we're still just trying to solve. Figure out what x equals. So I'm going to give you 2 times x minus 3 squared equals 3x plus 1. This equation is set up similar to vertex form, however it's not because of this extra 3x term. If that term wasn't there and it was in the vertex format, I would say solve by what method? So you're thinking about it and coming up with the square root method. But because of that extra 3x term, solving by square roots won't work. If you square root the right side, you're going to end up with an x under the radical, and that's messy. So we have to come up with another plan. So I can't solve by square roots because of this b term right here. That leaves factoring in the quadratic formula. It's definitely not in any shape to factor, so let's try to get it down into the format for the quadratic formula, which is into standard form, set equal to 0. So we have some work to do. Starting off, we're going to go ahead and distribute out the x minus 3 times another x minus 3 to get it into standard form. Can't distribute this square because of the subtraction symbol in that quantity. So I'm going to get x squared minus 3x minus another 3x plus 9. Combine like terms. Put it back in parentheses because I still have to distribute this 2. Once I distribute the 2, I'm going to get 2x squared minus 12x plus 18. And this is still equal to the 3x plus 1. We're closer, but it's still not set equal to 0. So I'm going to subtract these terms over, because they're both positive, and get 2x squared minus 15x plus 17 equals 0. From here, I could attempt to factor it by guessing and checking, or I can go ahead and use the quadratic formula. I'm going to use the quadratic formula and sing our lovely song. X equals negative b, and I'm turning it positive because b was already negative, plus or minus square root b squared minus 4ac all over 2a. Keep simplifying that down. Under the radical, I'm going to square the negative 15 to get positive 225. I only see one negative with the 4ac. 4 times 2 is 8. And if I go through and multiply 8 by 17, sorry, I'm just trying to grab a calculator real quick. 8 times 17 is 136. So I'm going to subtract 136 all over 4. Because this is not in the real world, when I do 225 minus 136 and get 89, which is not a perfect square, we are not going to change the square root of 89 to a decimal. We only do that with the real world scenarios. So from here, we have to decide whether 89 stays in, comes out, or we break it apart. You could try to break apart 89 and divide it by your perfect squares, but nothing is going to end up going into 89. So therefore, we're going to have to leave our answer like that. There would be a 1 in front of the radical, and 15, 1, and 4, if you look at all the terms, don't have anything in common. So this is going to just stay the way it is. 2 real solutions. One of them is plus, one of them is minus. So that's the example for day 8. And then you would hit pause because the next example you wouldn't do or see until day 10. Okay, so the second example, still solving. But just a different equation. And we're going to go ahead and solve the following. X minus 3 times x minus 1 minus 8 equals 0. I'm choosing this problem because you're probably really tempted to go ahead and just set x minus 3 equal to 0 and x minus 1 equal to 0 to get the solutions, the x-intercepts. This is intercept form, but it's not. And that's because of this extra term right here, the minus 8. That minus 8 is not being multiplied by the rest of it, therefore it is not in intercept form. Intercept form, everything's being multiplied. That's not an a value, it's an extra term. So since it's not factored, I can't set those factors equal to 0. I have to, just like in the one we did on day 8, distribute this out into standard form, which is what I'm going to do right now. You can drop down that minus 8 as well, and go ahead and combine like terms. And 3 minus 8 is negative 5. From here, you could choose your next method that you want to try to do to solve this problem. Remember, we can either solve it by factoring or square root, not square roots, quadratic formula. Can't do square roots because of this b term. Emphasize the b term. If there's a b term, you can't do square root method. So because the a value is 1, I'm going to try to see if it's factorable real quick. And there are factors of negative 5 that can add to negative 4, which will be x minus 5 and x plus 1 equals 0. Negative 5 times 1 is negative 5, and negative 5 plus 1 is negative 4. So the original problem wasn't in factored form, but now this is. And if you didn't recognize that that was factorable real quick, you could have done the quadratic formula, which would take a little bit longer. And you can probably do mental math at this point to set those factors equal to 0 to get 5 and negative 1. Okay, that's it. You guys are going to take the quiz. Remember, when it's left, the method is left up to you. I always like to look first, is there a b term? Because if there is not, or if it's in vertex form, I jump immediately to solving by square roots because that's the quickest of all the methods. Then I ask myself, is it quickly factorable using guessing and checking, especially when the a value is 1? And then last resort, if none of that's working, then go ahead and move on to the quadratic formula. That's when the option is left up to you. One other comment about your choice on method. When the c term is missing in standard form, factoring is way quicker than the quadratic formula. So I would do that method. Good luck on your quiz.